everybody. This is 4.4 day 1. Please make sure you can hear this. Make sure you can hear this. And I'm writing it down in case somebody's not playing the sound. It's very important to play this video with sound. Many people have played it without sound. I don't know why, but there you go. Hopefully people see the sign, and if they don't have sound, they'll play the sound. Okay. This is 4.4 day 1, trig functions of any angle. It's a relatively short assignment. Numbers 2 through 22, only the evens on page 499. Alright, now I'm actually going to flip ahead a few pages. The first few pages of examples are things we're pretty familiar with. I think it's best to just go ahead and jump into the first example. Okay? Now, this is a point P. Point P has an x value of 1 and a y value of -3. Now, if we're going to be working with this position on a coordinate system to figure out what the 6 trig functions would be based on that position, we're going to have to draw a triangle at that position. And we've been working in Chapter 4 with a lot of different types of triangles at different positions in the quadrants, quadrant 1, 2, 3, and 4, and then figuring out what the sine, cosine, tangent, and so far is from that position. The only difference now is that the lengths are going to be whole numbers instead of values like √3/2, 1/2, and so on. Okay? So, first step is to figure out what quadrant this triangle will be in. If x is positive and y is negative, it seems to me if this is the center of the coordinate system, I'm down here in the 4th quadrant. So, I'm going to draw myself a little sketch. Sketches are always helpful to kind of do a visual check of whether you're doing it right or not. This is 1 on the x-axis, and I'm going to go down about 3 of those equivalent markings. So that would be -1, -2, and -3. So +1 for x, -3 for y puts us at a position right here. Okay. Now, if I were to triangulate that position, that would mean it started here, it rotated all the way down and around over to here. So the terminal side would be right there. And again, this is the point 1, -3 right there. Now, to draw a triangle, we always go towards the x-axis from the end of the terminal side, and then back the origin. Now, from here, I would label the horizontal movement as +1, and I would label the vertical movement as -3. So I'm labeling the sides in the same way as I'm identifying that point. That's what we've been doing with our trigonometry. Now, the one thing that's going to be different from the triangles we've been positioning before in Chapter 4 is that the hypotenuse isn't going to be 1. Well, obviously, from here to here is 1. This couldn't possibly be 1. It's going to be longer than that, right? But we can still use the Pythagorean theorem to find that hypotenuse. So we have leg squared plus leg squared equals hypotenuse squared, which will give us 1 squared plus -3 squared equals, well, let's call it h squared. So if I add 1 plus 9, the hypotenuse squared is 10. So square rooting both sides identifies our hypotenuse as the square root of 10. Now, I don't know if you've noticed this, but I didn't put a plus or minus in front of this. Why didn't I do that? Normally we do. Whenever we take a regular number and we put a square root on top of it, we put a plus or minus in front, right? Well, I didn't do that because I know something that you may not know, and that is that the hypotenuse on these types of positional triangles is always positive. The x and y positions will vary, sometimes positive, sometimes negative, but the hypotenuse itself is always positive. So, I strongly recommend that you put that at the top of the page for your notes on this topic. Okay. Now I'm going to take my hypotenuse, I'm going to label it square root of 10. I'm also going to label it HYP for hypotenuse. Now I need to identify my opposite and my adjacent. Now, whatever that central angle of rotation is that's inside my triangle, that basically determines the distance between my terminal side and the x-axis, that is going to be my reference angle. So I only have 3 corners inside my triangle. Whatever corner is actually touching the origin, that corner inside my triangle is my reference angle. So here they've identified that as theta. So I'm going to call it theta here on the diagram as well. Once I have my reference angle, I should be able to identify -3 as my opposite side, and then 1 as my adjacent side. Okay, now what do we do? Well, we have to find our 6 trig functions. Well, let's start with sine. The sine of theta would be opposite over hypotenuse. Okay, now, we can't leave the radical in the denominator, so we simplify by multiplying the top and bottom by square root of 10. So I have -3 root 10 over the square root of 100, which is, if I scoot over a little bit, -3 root 10 over 10. Now, I have, I can move this up a little bit. Sorry, I'm adjusting my vertical height away from the document. There we go, so I can get it wider. There, nice. Okay. Now, the reciprocal of sine would be cosecant, right? Remember, if sine starts with S, then its reciprocal starts with C. Now, instead of taking this answer and flipping it upside down, which would give me a radical in the denominator, I'm going to go back to my original answer for sine, the one that I had to simplify. If I take this original answer with the opposite over the hypotenuse and flip that upside down, that would make my life a lot easier. That would just be root 10 over -3, or if you prefer, negative root 10 over 3 like so. Either way is fine. I'll take this one since I wrote it down. And there's your inverse. Now you'd certainly be able to get this same answer by taking this, flipping it upside down, and then simplifying, but it would be a lot of extra work. There's no need to do that. Just go with your original answer, flip it. There you go. And like I said, this one is perfectly fine too. I just moved the negative to the center. Okay, what's next? Cosine. Cosine of our reference angle would be adjacent over hypotenuse, which we would multiply by root 10 over root 10, which gives us root 10 over root 100, which is just the square root of 10 over 10. Again, we're going to try to work smarter, not harder, in finding the reciprocal of cosine. Cosine's reciprocal starts with an S, secant. And instead of flipping this one upside down, which would give us more work to do, I'm going to flip the original one upside down. 1 over root 10 would be root 10 over 1, which is just plain old root 10, right? Alright, then the last two are the fastest ones to find. Tangent would be opposite over adjacent, -3 over 1, which is -3. And then cotangent is the upside down version of that, 1 over -3, which you could write as -1/3. Either way is fine. Let's take this one. There you go. You found your 6 trig functions based on a position defined by a coordinate point. Alright. Moving on. Evaluate if possible the cosine function of the following 4 quadrant angles. Well, 0 degrees. Remember, when we start rotating, 0 degrees is always pointing towards the right. So if we have our coordinate system that looks like this, and we're pointing towards the right, well, what we can do, if they don't give us any other information other than the angle, is assume one thing. Assume you have a unit circle. Unit circles have a radius of exactly 1. That's why they're called unit. Uni means 1. UNI. So if we have a unit circle and we're at 0 degrees, basically we're right here, right? Well, if the radius is 1, wouldn't the distance from here to here be 1? Yeah. So this position right here as a coordinate, the x value would be 1 since I'm 1 to the right of the origin, and the y value would be 0 since I'm neither above or below the origin. Right? Right. Now, in previous sections we've defined cosine as x on a unit circle and sine as y. And we're going to continue that today. On a unit circle, if I want to find the cosine of a certain position, I simply figure out what the x value at that point would be, and that's my cosine. So the cosine of 0 degrees is the x value. Cosine is x, so the answer is 1. Now, number 2 would be down here, 180 degrees. Here's 0, here's 180 over here. So, on this system, I would start here, I would rotate all the way over to here. Again, we're assuming that the distance we are from the center is always 1. So now the x value would be negative 1, because I'm to the left of the origin 1 step on a unit circle. And the y value, since I'm neither above or below the origin, would be 0. Okay, so if x is negative 1 and y is 0, the cosine at this position at 180 degrees would be whatever the x is. So in that case, it's negative 1. At 90 degrees, you may be able to figure this out at this point. At 90 degrees, we're up here. Again, we're assuming we're on a unit circle, so I'm assuming this distance here is 1. So since my x value is 0, I'm neither left or right of the origin, but my y value is up 1 unit from the center, that would be 1. Then, therefore, the cosine of 90 degrees, cosine always being your x value, is 0. And then finally at 270, we would be here's 0, here's 90, here's 180. Turns out this position down here is 270. So I made it a little bit lower than the other ones. Let me just adjust it. Okay, try to stay roughly in consistency with the other examples. Okay, so I'm assuming that, again, I'm somewhere on a unit circle, therefore the distance away from the origin is 1. Now the x value again is 0. I'm neither left or right, so I'm at 0. The y value is down here, 1 unit below the origin, so we would say that is at negative 1. Okay, so the cosine of 270 degrees would be the x value at that position, which is 0. Again, I got a little bubble down here. Gotta fix that. Come on. There. Slightly better. Okay. Now, the next page is essentially more of the same. We're going to assume we're on a unit circle. This time we're going to go around and find the sine values. But be careful. This can be, I'm sorry, not the sine values, the cosecant values. But be careful, this one's going to be a little bit harder, so continue to pay attention. Reciprocal values can be a little tricky. They're not going to be as straightforward as just finding sine or cosine. So here we go. We're finding cosecant, right? Again, we're going to assume we're on a unit circle. And for cosecant, well, that's abbreviated CSC, right? Now, that is the reciprocal of sine. So what I'm going to do is I'm going to find the sine of the angle, and then I'll flip that upside down, and that'll be the cosecant of that angle. So that's my basic goal here, my steps. Okay, so 0 degrees. Okay, if I'm somewhere on a unit circle, at 0 degrees I'm over here. Again, I'm assuming from the center to here is 1 unit. So my x value would be 1 and my y value would be 0. X, y. Now previously on unit circles, we've identified that sine is basically the same as y. Sine is your y value on a unit circle. So if my sine of 0 degrees is 0, how in the world am I going to figure out the cosecant of 0 degrees? Well, if I take 0 and I put it over 1, you can take any number and divide it by 1 and it's still going to be itself, right? And then if I take that and flip it upside down, that would be 1 divided by 0, right? For the reciprocal. So 0 is this, upside down version of that is that. So the cosecant of 0 degrees is 1 divided by 0. Okay, well in mathematics we can't divide by 0, it's not allowed. So instead of just saying no answer, we use the phrase undefined. And that's actually my final answer for number 6. Okay, 90 degrees. On our coordinate system, 90 degrees is here. Again, we're assuming we're somewhere on a unit circle, so the distance from that position back to the origin will be 1. So if that's 1, then my x value is 0 and my y value is positive 1. Since sine of 90 degrees would just be that y value on a unit circle, sine is 1. Or, if you really wanted to, we could call it 1 divided by 1, right? So finding cosecant, I can take that fraction, flip it upside down, it becomes the same exact thing, which simplifies back to 1. So strangely enough, it turns out that the sine and its reciprocal, cosecant, at 90 degrees are the same answer. They're both 1. Oops, there we go. Okay. Well, how about 180? 180 is half a circle, so if 0 is here, we rotate the positive direction all the way over to there. Okay, I'm assuming I'm on a unit circle, so the distance from the center to the side is 1. That makes my x value negative 1 and my y value 0. So, I'm going to first find sine of 180 degrees. That's just y, so that would be 0. Remember, cosine is x and sine is y, so I'm just stealing the y value from that point. Now, you may notice that we got the same answer in number 6. When the answer is 0, we could also write it as 0 over 1. And yet again, just as in number 6, if I try to flip that upside down, it becomes 1 over 0, which is also undefined. Can't divide by 0 in math. It's not allowed. And then finally, number 9. If we have 0, 90, 180, 270 would be down here. And what have we got? We've got 1 unit away from the origin. We're assuming we're on a unit circle with a radius of 1. So my x value is 0 and my y value is going down 1 unit. So that would be negative 1. Okay, x and y. Here we go. The sine value of 270 degrees is my y value at that position, negative 1. Now if I want to turn that into a fraction, I can take any number and divide it by 1. So there's the fraction version of negative 1. So cosecant of 270 would be that upside down, 1 divided by negative 1. Which, if I divide 1 by negative 1, yet again I get back to the original answer, which was negative 1. Now, this page is just to get you to start thinking about quadrants, and other math teachers like to share this, that all functions are positive in quadrant 1, sine and cosecant are positive in quadrant 2, and so on. For me, this little memory trick really hasn't worked. I think we can just use what we already know about quadrants and figure it out without having to kind of work from this template. But I did write this just in case some of you had already seen it and wanted just a refresher on what that phrase was, all snowflakes taste cold. So, like I said, I'm not a fan of that, so I'm not going to explain the whole thing and how it works. I think I'm just going to explain these last 4 examples based on what you already know. Okay. Now, on a unit circle, sine is your y value, and cosine is your x value, right? So, we can try to figure out what quadrant each of these angles lies in by taking the clues about what x and y could possibly be. Obviously, if both x and y are positive, we're in the first quadrant. If x is negative and y is positive, we're in the second quadrant. If they're both negative, we're in the third quadrant, and if x is positive and y is negative, then we're in the fourth quadrant. So basically the quadrants look like this. The x value will be positive and the y value positive here, x value negative and y value positive here in quadrant 2. In quadrant 3, they'd both be negative. And in quadrant 4, the x value will be positive and the y value is negative. So I just wrote them as coordinate points x, y in each quadrant. I don't know if that's helpful. If you want to draw this quick little diagram, I'm going to be pointing to it as I go through. Quadrants 1, 2, 3, and 4. Okay? Okay. If sine is less than 0, if something's less than 0, it must be negative, right? So, sine, since that's my y value, instead of writing sine, I'm going to write y. And then, instead of saying something's less than 0, I'm going to say that it is negative. I'm going to abbreviate negative as neg. Cosine, well, that's the same as my x value. And instead of saying that something is greater than 0, in normal language, instead of math language, we simply say that it is positive. So I'm going to abbreviate that POS. So if the x value is positive and the y value is negative, what quadrant am I in? Well, that would be quadrant 4. So my answer here for number 10 is quadrant 4. Sine is less than 0. That means that y would be negative. Oh, now it gets interesting. Tangent is not x or y, it's a combination of the two. Tangent can be defined as sine over cosine, right? Or we could call tangent y divided by x. Sine over cosine, y over x, same thing. Now, it says that this is greater than 0, which makes this entire fraction positive. Anything greater than 0 is something positive. Well, what we're trying to do here is build a clue for ourselves. We're trying to figure out what x is, whether x is positive or negative. Because once we know that, we also know y is negative, and we can figure out what quadrant we're in. So really the whole idea here is to build enough information to figure out what x is, positive or negative. Now, this fraction, I know the top number is negative because over here I already know that y is negative. That's a clue I picked up from the first bit of information. So I'm going to write a negative sign with a circle around it on the top of my fraction. Now, if the entire fraction is positive, the only possible signed value I could have in the denominator would be a negative, right? Because only a negative divided by a negative would give you a positive overall fraction. If x were positive, I'd have a negative divided by a positive, and that whole fraction would be negative. So I'm going to then conclude that x is a negative value. X is negative. Alright, so now I know that both x and y are negative. So if I wrote it as a coordinate point, I'd have a negative number for x and a negative number for y. And those types of points are only found in the position of an angle that ends in somewhere in quadrant 3. So that is my final answer for number 11. Quadrant 3. Okay. This is where it gets a little bit trickier, not too bad. Basically, I have secant. Now, secant is defined as the reciprocal of cosine. So you could think of secant as being 1 over x. And basically, because secant comes from x, whatever x is, if x is positive, cosine's positive, and secant will also be positive because it would just be 1 over that value. Or if cosine, let's say, is the fraction 2/3, secant would be 3/2, right? It wouldn't change the sign of it. It would just change the position of the values in the fractional formation. So hopefully you understand that whatever x is, positive or negative, will influence what cosine is, positive or negative, which will then also influence what secant is, positive or negative. So if x is positive, cosine's positive, secant's positive. Or if x is negative, cosine's negative, and secant's negative, right? So they all kind of go together as a signed group. All three of these values will be positive together or negative together because their definitions are intertwined. They are a set. Okay, so hopefully you recognize, hopefully I've convinced you that the secant will be the same sign as x. So I'm going to say that it gives us a clue about the sign of x. If secant is greater than 0, that means it's positive, right? Well, that means that all three of these are going to be positive. So I'm going to say that x is positive. Now I'm going to do something that's very similar to what I did here. Remember how I said that tangent is sine over cosine, or in this case I could call it y over x? Well, cotangent is the reciprocal of tangent. So I could either call cotangent cosine over sine, or I could call it x over y. And that's what I'm going to choose to do. I'm going to call cotangent x divided by y. That's this part of the statement here. If I have the fact that cotangent is less than 0, that means that that is negative, that this entire fraction is negative. Okay, now this statement will help me figure out the value of y, or at least what the sign is, either positive or negative. So I already know, based on the first clue, that x is positive. So that means the top part of my fraction here is positive. So instead of writing x, I'm going to put a plus sign with a circle around it, indicating that that top number is positive. Now, if the entire fraction is negative, there's no way that y could be positive, right? Because if you have a positive number divided by a positive number, that doesn't give you a negative fraction. No. The only way to make this entire fraction a negative would be now to include a negative in the denominator, right? So y would have to be negative in order for this to work. as a negative fraction overall. So I'm going to make a conclusion then, based on the information that I have and all these clues put together, that y has to be a negative value. And now I should be able to figure out what quadrant I'm in. If y is negative and x is positive, x being positive, y being negative, then that would mean I'm in quadrant 4, where the x values are always positive and the y values are always negative. So my final answer for number 12 is quadrant 4. Okay. Now, the last one is very similar to the one we just did. I'm actually going to start over here with cosecant. Cosecant is defined based on what sine is. So if sine is positive, then cosecant will be positive. Or if sine is negative, then cosecant will be negative. And since sine is simply a reflection of my y value, all three of these things, y, sine, and cosecant, will all be positive or they'll all be negative. They kind of go together as a group, just as x, cosine, and secant are. So if they're telling me that cosecant is less than 0, they're trying to tell me that something is negative. Being less than 0 means that you're negative, right? And if cosecant is negative, that means all three of these values are negative. So that must mean that y is negative as well. And then over here, since we've been defining tangent as y over x, since we're trying to thinking about x and y values, tangent is the fraction y over x. And this right here says less than 0. That means that the entire fraction is negative. Now I can put it all together. Now I can say, okay, since this other clue on the right-hand side said that y is negative, that must mean that the top of my fraction is negative. So I'm going to use a negative sign with a circle around it to indicate that I don't know the number exactly, but I do know that it's negative in the numerator. So if the entire fraction is a negative fraction, that must mean that the denominator is, well, if it was a negative x, a negative divided by a negative would be a positive fraction, not a negative fraction. So it makes sense that x would have to be positive, because a negative over a positive gives you an overall fraction that is negative. So therefore, I'm going to conclude that x has to be a positive value. So I now have my x and y values identified in sign terms. So x is positive, y is negative, and yet again, I didn't try to pick a bunch of examples from quadrant 4, but yet again we're in quadrant 4. Not everything ends up in quadrant 4, obviously. Example number 11 was in quadrant 3. But I just happened to pick some examples where there was a predominance of quadrant 4 answers. Okay, there you go, folks. If you want to play the video again and maybe pause at a certain screen or hear some sort of explanation again, please ask your person running the video to do that. Again, your assignment is page 499, 2 through 22 even. Maybe you can use some class time working on your assignment. The books are in the brown cubby shelf between the two file cabinets and the corner shelf.